you.
It's fine. All right, so Hackathon, November 17th. That's a Saturday. And that's from, what, 8 a.m. to 8 p.m.? Is that the time on it? That's what it usually is. All right, so I require this for all my classes. So you should ask for work off or whatever you need to do for this Saturday. If you are not able to make it, there is a penalty assignment that you will hate. Okay, so if you absolutely can't make it, there will be a long paper that you have to write in instead that will equal 12 hours of work.
Oh my goodness.
Well, you're coming for 12 hours of hackathon. Yeah.
So what if, like, I know I have an hackathon.
Yeah.
I go to, like, I can check this on my way, but
Yeah.
go to, like, what I can go to?
Possibly. It depends on, I mean, we've had students like leave a couple hours early or show up a couple hours late before, but you probably need to be there for at least most of it. So figure out when the game is and message me and we can figure it out. All right, so that's the hackathon. Make sure you mark it on your calendar, blah, blah, blah. It's here in the department, and it'll be 12 hours of programming. What we do is we split you, if you haven't done it before, we split you into all of you should have done it before because we did it last semester, but we split you into teams based on kind of your skill level. So weaker programmers will go with more advanced programmers, so you get to learn some stuff. And I think that this year's topic is going to be on machine learning. So I'll be running a boot camp either, I don't know, someday earlier that week, probably Tuesday or Wednesday. We'll settle the day, but I'll record it. Where I think I'm looking at either IBM Watson or Amazon machine learning ML. And so one of those two I'll pick and I'll give a boot camp on using that machine learning, and then that'll allow you to kind of brainstorm ideas. I will announce teams ahead of the hackathon, maybe even about a week ahead. So sign up as soon as possible by emailing Professor Josh Locklear. So his email address should be on there, joshua.locklear@cu.edu. So get on the list as soon as possible so I can start thinking about teams. Yeah, any questions about hackathon? All right, so we're all excited. Well, I mean, machine learning should be fun, right?
Yeah.
Yeah. All right, so midterm. Midterm is Thursday. There will be 10 questions, each worth 10 points. My usual exam. Remember my policy that if you do better on the final exam than you do on the midterm, I'll replace your midterm exam grade with what you get in your final exam. So hopefully this exam gives you an idea of where you stand relative to where you should be, and it gives you an opportunity to improve things and undo any damage you do to your grade on the exam. Make sense? All right, so I'm going to go ahead and go through the slides up to this point and kind of point out the areas, the things that I think are extra important to look at, because this is the same process I'll go through when I write the exam. All right. So there will be probably at least 3 or 4 programming questions on the test. Okay, so expect to write some code. There will likely only be one problem that has you write a more complex algorithm. Most of the programming questions might have you like write a for loop that spins through a string, proving that you can write loops and things like that. And so things that aren't real difficult for you to figure out the logic for, but things that are proving that you kind of know how to use the length of a string and how to get the character at a particular bucket in a string, that kind of stuff. All right, so 3 or 4 programming questions. There might be a couple of questions where I give you some code and ask you to tell me what does this code do. Okay, and again, when I show you stuff like that, I'm not asking you to describe each individual line telling me what does that particular line do. I want you to tell me what does this code as a whole do. Does it go through an array of numbers and figure out what the largest of them is? Something like that. I mean, if you want to go line by line, that's okay, but ultimately you need to tell me what does the entire program do. All right, because that proves that you know how to read code. Make sense? All right, so how do humans solve problems? One way or another, this is going to be represented on the exam, but probably not just a straight question, asking you to list the 3 ways humans solve problems and how does that map to programming languages, but that should be something you are familiar with. Same thing with history of languages. I won't ask you anything direct from this, but I'll kind of bring it back up in a little bit, but something that they're like the transition between C++ and Java and what did we lose with Java might be somewhat important. I'll point that out here in a little bit, but I wouldn't ask you to like recreate this chart or something like that. Okay. I wouldn't ask you to recreate this slide in specifics, but if I ask you a question about like compilers and what's the job of a compiler or something like that, where it converts a high-level language to a low-level language, that should be something you should be able to answer. If I ask what's the difference between a low-level language and a high-level language, that's something you should be capable of doing as well. What is the difference between a low-level language and a high-level language?
Like low level has a one-to-one relationship with what the processor is doing. High level has a more broad, like one line can do like multiple things.
Yeah, one to many. Yep. All right. So we like high level languages. You write one line of code, a whole bunch of stuff happens behind the scenes, a whole bunch of magic tricks happen on the CPU. A low level language is a one-to-one relationship. So like some of the stuff we've been looking at in 325 for the couple of you that are in that class. Where every single little line does something granular on the CPU, and it's can be kind of annoying over time, but not as bad as machine language. All right, so I probably won't ask anything about interpreted versus compiled languages. I mean, I might ask, the idea of a compiler convert from high level to low level, but this was 200 stuff that we just reviewed at the beginning, so I probably wouldn't ask anything specific about that. Compiler could find its way on there one way or another. We should understand the purpose of that guy. Loosely typed versus strongly typed. I probably won't ask anything directly related to that. I mean, you should probably understand the difference, especially since you're working in a strongly typed language now. Last semester you worked in the loosely typed language, but I won't waste my time or your time asking a very specific question like what's the difference or something. I probably wouldn't ask anything direct about this slide. It's possible there could be something on the test dealing with the Java virtual machine, asking, like why is Java technically a slower language than like a language like C++? So C++ and C, these guys compile directly to executable language, some machine language, whereas Java gets compiled to this intermediate language called Java bytecode and then ultimately runs on a piece of software called the Java virtual machine, which then maps it to the CPU. So it gets translated right here between Java's low-level language and your Intel low-level language, let's say, for your CPU. So Java would be slower because of, maybe from a human perspective, you might not notice, but Java would be a slower language because it's having to go through this last piece of translation where C and C++ do not have to do that. All right. You should be familiar with this. It would be a fair question to ask what kind of programming language is Java, so you should be able to kind of pigeonhole it into where it fits in the big scheme of things. Out of all of these languages here and all of these, there are 3 kinds, there are 2 kinds, all this stuff. The very least, the language we're focusing on this semester is Java, so you should be able to fit that into the genre of language that it is. It's a high level, general purpose, strongly typed, compiled, object oriented, and then we can also say it's a platform independent programming language. So all those things kind of point to, the summary of Java. Okay, that's the elevator pitch for what is Java. All right, so we started talking about types, so this will definitely find its way onto the exam in one form or another. So we have two broad types in most programming languages, Java being, since it's a derivative of C, C, which is a derivative of C++, which is a derivative of C. It has the primitive types that came from C, and then it also has object type values. All right, so our primitive types, you should know that list of primitive types. I don't know if I'll ask you to specifically list it, but you should be able to list the, byte, short, int, long, char, float, double, and Boolean. You should be able to list all of those guys. I will not ask you to say the size of the values. You won't have to know that you should know that a byte is 8 bits, but that 16 bits is a short, 32 bits is an int. You don't have to know that stuff. It would be fair game for me, though, to ask a question like, why do we have so many different ways of holding whole numbers, whole integer values? Why is that? Why do we have byte, short, int, and long, 4 different ways of holding signed whole numbers?
Memory used to be expensive.
Yeah, memory was expensive, so a language like C gave us the granular control to choose a variable type that fit into the right footprint size for us to, if we only needed to hold values between 1 and 10, a byte is sufficient. Anybody know what's the range of values that a byte can hold?
1 byte equals 8.
It's 8 bits. So what's the maximum number of, what's the maximum value that we can store? What's the smallest value and what's the largest value we can store inside of a byte? It's a signed number.
Is it 255?
Well, 8 bits unsigned would be 256, 0 to 255. That's unsigned. It's a signed number, which means it can hold positive and negative values. Negative 128 to positive 127. So generically speaking, you say it's plus or minus 2 to the 7th power. 8-bit number, 2 to the 7th is our magnitude. One of the bits is used for sign, roughly. If you're in the 325 class, we've learned that we use 2's complement to represent the negative numbers. So it's not as simple as just saying that 1 bit is used for sign, but 1 bit's used for sign, one way or another. All right, so we have 7 bits that are used for the magnitude of the value and 1 bit used for the sign. So a byte can hold negative 128 to positive 127. A short can hold plus or minus 2 to the 15th power. An int can hold plus or minus 2 to the 31st power. A long can hold plus or minus 2 to the 63rd power, so on and so forth. Okay, but on the exam, I won't ask you about the size of those values. Okay, but you should know what the size of a byte is. That's more of a generic computers, like how do computers work term. Okay, but I won't ask you that. But you should be able to list the different primitive types and even tell me the kinds of values that they hold. Okay, so we already discussed byte, short, int, long. What kind of values do those guys hold?
Signed numbers.
Signed whole integers, right? Signed whole numbers, right? Okay, what about a char? What kind of value does chars hold?
Unsigned numbers.
Unsigned whole numbers, right? So that's almost the trick question, right? So we think of chars as being like the character A or the character 7 or the character question mark, something like that. But that's how that's what they ultimately map to. What actually gets stored inside of a char primitive type is an unsigned 16-bit integer. Again, you don't have to know the 16-bit part. Probably should, but I'm not going to ask you about the 16-bit part, but you should know that chars, that type actually holds unsigned numbers. What does it mean for a number to be unsigned?
It's not positive or negative.
Yeah, can't hold negative values. It's not positive or negative. So that means we get the entire bit space to hold the number. So whereas a 16-bit short, which is a signed number, can hold values negative 32,768 to positive 32,767. A unsigned 16-bit number like a char can hold values between 0 and 65,535. Make sense? Everybody got that memorized?
Yep.
just got it. It's in there.
2 to the 60.
Yeah. 0 to 2 to the 16th minus 1.
Okay.
Yeah. What was I talking about? Okay, yeah. So chars hold unsigned whole numbers. Floats and doubles hold floating point values, so things with decimal points in them, signed. And then Booleans hold trues and falses. All right, so you should know all those types. I don't know how I might ask the question, but somewhere on the exam, you are going to be responsible for understanding what primitive types are and what primitive types exist in Java. Go ahead.
First, this is all like completely short answer, right?
Yeah. There won't be no bubble in or true false or multiple choice. Yeah, I don't.
Okay, and then so you gave like primitive type like examples. What would be like object?
Yeah, so object types. Yeah, so object types, the ones we've messed with the most, well, really the one that we've messed with a ton is strings. Okay, so an object type, this guy can hold 0 or more values. So a primitive type can only hold a single value. That's all it can do. Okay, so we just talked about the different kinds of values we can hold with primitive types, but the entire talent pool of a primitive type is to hold one value, okay, of a certain type. Where an object can hold, doesn't even have to hold a value if we don't want it to, okay, but an object type can hold 0 or it can hold 50 values, 1,000 values if we want it to hold a whole bunch of different values. So those are the fields in there. But then it also has a collection of constructors and methods that we can have associated with that object for performing operations with that object. So we've messed with like the random object as well to get next int, right? We've done random numbers in here, haven't we? Pretty sure. Yeah, so but then an object in general, we talked about that when we talked about the difference between procedural languages and object-oriented languages. So that's like the telephone, pile of wires versus the object-oriented version of a telephone actually looks like a telephone. And inside of that is all the functionality of the telephone. Okay, so our object type variables are much more talented than our primitive type variables that can only hold a value. That makes sense? So even just thinking about strings, we know about the length method, we know about char at, we know about index of, we know about, I think we probably showed 2 uppercase and 2 lowercase at some point or something like that. There's a whole bunch of methods it knows. You won't have to memorize all the methods from the string class, but you should definitely know the length method, the char at method, and we've used the index of method quite a bit too, right? Index of is the inverse of char at. Okay. But at the very least, you should know length and char at off the top of your head. Okay. So those are 2 pretty common methods for strings, right? How many characters are in the string and how do I get one of the characters? Okay. Those should be in there somewhere. You don't need to know the whole collection of methods. If there's a method I want you to use, I would provide you the definition of the method, and you would have to show me you know how to use it by proving you know whether it's a class method or an instance method and how do you call class methods versus instance methods. I promise you that concept will be on there at least twice. Okay, by twice I mean 10 times. Okay. If there are 10 questions, it's going to be on there 11 times. Okay. You will need to understand that concept and have it straight in your head. How do you identify a class method versus an instance method if you're looking at the method definition? How do you identify a class method versus an instance method if you're looking at it being used? And you should be able to, if you see a definition, you should be able to call that method accurately, so on and so forth. Okay? If you don't have that concept straight in your head, you're probably looking at you're probably going to miss 30 points on the test, would be my guesstimate. Make sense? So get that concept straight. Super important concept, and it will haunt you on the exam if you don't understand it.
Do we have conversion?
Who?
Do we have conversion questions?
Oh, there'll definitely be a conversion question. Yeah. Any exam you ever have with me will have a conversion question on at least one. Yeah, it's just like a given. Yeah, in every single class. Those of you who are in 325, you might have a little more than one conversion question on the exam. But yeah, I would look forward to having at least one conversion question, probably only one conversion question in here where I ask you to convert some number from decimal to hexadecimal, or from binary to hexadecimal, or from octal to decimal, you know, something like that. So know those two patterns. How do I go from decimal to some other base? How do I go to from some base back to decimal? Okay, we've written programs we did it in Python and we wrote it again in Java, right? So we've written programs in both of those. I believe you wrote it in Java in here. We not written it in Java? But we definitely wrote it in Python.
Yeah.
Yeah. So you've written code that does that. So you should completely understand that algorithm. Okay. Again, you know, understand the difference between the types and be able to tell me about those types, blah, blah, blah. So there's our primitive types: byte, short, int, long, char, float, double, Boolean. Like I said, you don't need to know the size, but you should know the kinds of values they hold. Specifically, the trick one here is char, unsigned whole numbers. Okay, that's like the third, fourth, or fifth time I've said that today, so no excuse on the exam for you to say chars hold characters. Make sense? Okay. They represent characters at the end of the day, but they hold whole unsigned numbers. All right, so obviously you should know the syntax for creating variables in Java. I probably wouldn't ask you a question like, what is the generic syntax for defining a variable? But there will be plenty of opportunities where you're either reading code that I wrote where I define a variable and you should know what that looks like, or you have to define your own variable and you should be able to do that as well, right? So it's the type followed by the variable name equals whatever the value is for that. So you should be comfortable with the generic syntax. And this links back to that slide that deals with the mapping. How do human beings solve problems? We represent memory through variables. We represent asking questions through conditionals. We represent repetition through loops and functions. So you should know how to define variables and read code where a variable is being defined. You should know how to write an if statement and be able to read a if statement if one is provided for you so you can see how the logic works. You should be able to write our loops. We've spent quite a bit of time writing kind of those standard, you know, here's our go-to loop for spinning through a string. Here's our go-to loop for spinning through an array, that type of stuff. Okay, these should be second nature for you. So make sure you can almost treat those like primitive types, where those are skills that you should just have, where you can write the generic structure of a for loop and then tweak it for the actual problem you're solving. Make sense? Okay, and the reality is that once you have it, you pick any programming language. Once you know how to define variables, ask questions, write loops, and write methods, you already know how to solve a whole bunch of problems in that language, even if you just learned the language 5 minutes ago. Make sense? How was that? All right, so the idea of variable resolution, this will definitely find its way in the exam. Probably there will be some question where I give you some code and I ask you, what does this code do? And it's going to rely on you, when you look at variables, resolving what that variable's value actually is. So for instance, you might be looking at something that's a string, and if S is a string, s.char at 3 is actually a char. Okay, so you have to recognize that just because it started as a string doesn't mean that I'm dealing with a string there.
Doesn't char hold unsigned whole numbers?
Yeah, but that's what a char is. So if S is a string, s.char at 3 would give me the character that lives at bucket 3 in S as a char. Yep. So make sure you know how to resolve code. So you can tell me what kind of thing you're actually, I often will say, what kind of animal am I dealing with here, right? Okay, so when you resolve a variable, you're going to get some value. And if you, at a glance, you might assume the value will be a string or something like that, but once it's actually resolved, it might come out to something else. Really common for like Boolean expressions, right? You might have all sorts of different things dealing in this giant Boolean expression, but at the end of the day, it's going to be a single value of true or false. Make sense? So practice reading code and taking your time to understand what does this code actually boil down to. And that's going to help you then answer the question of what does this chunk of code ultimately do. Okay, and as another reminder, so I can claim that I said this multiple times. When I ask you, I give you a chunk of code and I ask you, what does this code do? I'm not asking you to say this line defines a variable named I and sets it to 7. Then, you can do that if you'd like, but ultimately I want you to give me a sentence or two that tells me as a whole, what does this chunk of code accomplish? That makes sense? That's what I'm asking for. So we've heard me say it multiple times, right? Okay, so when I get crap answers on the exam, and I could say I talked about this multiple times, there's no whining, right?
You didn't say that in class.
It's like spoken like Trump. It's just, I don't know what you're talking about. I was never said. All right.
There's no video of this lecture.
This is nothing. Did I hit record? I think I hit record. Pretty sure I hit record. All right, so like here, here's an example. What are the 4 prototype integers? Why do they have so many ways of storing them? That if we asked a quiz on something, there's a reasonable chance it's going to be represented on the exam in one form or another. Probably something that was relatively important.
You said that the reason there was so many
memory used to be really expensive. And because Java came from C++, which came from C, which is a very old language, you had all these different types for holding integers because back then memory was really expensive. So, if you only needed to hold a number that was, in the range of -128 to +127, you would choose to put that into a byte rather than a short because you might be running out of memory. So memory was expensive and it wasn't very big. So those were important things so as a programmer, we had to care about more stuff. Today, we really should care about those things, but because we have technology surrounding us and the cost of things is, you have 8 gigs of RAM. That's a lot of ints. Oh yeah, I mean, this phone has 8 gigs of RAM in it. There's 8 gigs of RAM and 512 gigs of internal storage, expandable to a terabyte. Who needs that in a phone? Yeah. Actually, the 512 I didn't care about. The only reason I got the biggest Note 9 was because I wanted the 8 gigs of RAM instead of the stock 6. There wasn't you can't get like a 64 gig version with the 8. If you wanted the superpower one, they say give us your $1,700, and then we'll give you an 8 gigabyte phone. I don't think it's 17. I think it's like 1,500. But
what did you do with that?
Huh?
What have you done to test it yet?
Well, hey, actually, an interesting thing is I have this optimize button, and pretty commonly, like right now, I have 3.6 gigs free of memory. So that means if I only had 6 gigs, I only have 1.6 gigs free of memory, and I don't even have any apps open right now. So
what are you running?
I don't know. Whatever I opened the last several days. I spent about a half hour last night watching the Warriors Phoenix basketball game on NextVR Live, going from Oculus Go to for this phone you can use Gear VR, but I don't like taking my case off, so I actually use a Google View. So the Google Daydream setup. So I was seeing which one looked better. Is it going to look and run better on a $1,500 phone or on a $200 Oculus Go? What do you think the answer was?
Yes.
$200 Oculus Go.
How much was your phone?
Like $1,500 or something.
There was a phone.
Oh yeah, just look at the newest Apple phones and look at the newest Samsung phones. Pretty quickly you could find phones that cost that much. A couple of years ago it was like, oh, this is the first $1,000 phone. Yes. That's so 2015. I mean, the first $1,000 phone. You can't even get a feature phone for $1,000. You can't actually. Yeah, I think this phone, the Note 9, I think maybe starts at $900 if you get the lower capacity ones. It's just gotten out of hand, right? But I get a new one every year. I just sell it, and so I get most of the value back, or 70% of the value back and then put it towards the next one. And so I rented it for 30% of that for the year.
Then we'll get is it the Samsung like X or whatever? It's gonna be like $2,000.
Oh, is that the one they're talking about? It's going to be folding. I don't know if I buy into that. Man, I'm all about a bigger screen. So if that's the case, I'm good with that.
It's supposed to be like a phone, and then you flip it, and it's supposed to have 3 screens. So it's like a normal phone. You like flip it open, and it's like a tablet.
Yeah, and I'm down with that as long as it's like, you know, like reasonable to carry and, you know, not flopping open on its own and stuff like that. But, you know, I'm just upset that they put so much of this other technology, like with fingerprint stuff and face recognition, and this has iris recognition and all that. I don't know. I'm just, well, he probably wishes they had more security. I mean, I want this thing testing my blood. You just can't trust face recognition. I have no security on mine. You just come up and push the button, you're in.
Push one and the needle comes out.
Yeah, I mean, it's I don't know.
You should get that so I can take a look at it.
Get what? The foldable phone?
Mm-hmm.
Well, I will. I mean, if it's good. I mean, I don't look at the price tag of it. Well, in my business, I got to keep up with the latest tech anyways. Plus, I'm a tech geek, so I want to have the coolest stuff. But I won't just buy something because it is expensive. I want it to sound cool, and then I don't care about the price. If it sounds cool, I'll get it. But I'm not just going to spend a bunch of money on something like I don't drive like a super expensive car. I mean, I have a nice car, but I don't need a Ferrari because my car gets me to work just fine. So actually, I wouldn't fit in a Ferrari. You need the jaws of life on the way in and on the way out. I would need my own pit crew. Like, what are you guys doing? I'm here to get Lippin into his car. Man, you're carrying an awful lot of butter. All right. So, as I mentioned before, you should be able to write an if statement. I'm not going to ask you a question like what's the formal syntax for an if statement. This was, you know, how I originally introduced it, but you should be able to ask questions in Java. Just like you, at this point, you should be able to ask questions in Python. And you should all be able to ask questions in C#. Even though many of you never tried C#. Same questions you ask in Java, the identical syntax. Okay, same thing's true of C++ and C. Okay, so you can tell you where those where our if statements come from. They came from C. Well, came from even before C, but from our more localized historical view of programming languages, a high percentage of the code we write in Java today came from code from late 1960s. Know what a Boolean expression is? I probably won't ask you that as a direct question. That's more of a 200 concept, right? But you should certainly be comfortable with Boolean expressions by now. Using them in if statements, using them in loops, that kind of stuff. You know, we talked about a block statement. I'm probably not going to ask you anything specific about what a block statement is, but this was kind of talking about when you have the opening and closing curly braces, it's a collection of 0 or more statements in there. And I've kind of advertised that when you have an if statement or you have a loop, you should always use the curly braces. And several of you in here can vouch for on your homework. I don't take off points, but I've given you little comments. I think aren't you one of them? I give you little comments that encourages you to always use the curly braces, even though it might be clear that you understand that when you need curly braces and when you don't. If you always use the curly braces, you'll never run into problems. All right. So good rule of thumb is if you have an if statement, always put an opening and closing curly brace after it. If you have a loop, always put an opening and closing curly brace after it. I won't take off points if you don't, but I also won't have sympathy if you don't put them there and did it wrong. Okay, because that shows me that you didn't earn the right to not put them there because you didn't really know what you were doing. You just didn't put them there. Make sense? All right. Same thing. Our loops. you should understand the 3 different kinds of loops. I would say there's a 20% chance I might even give you a direct question on that. Like what's a for loop, what's a while loop, what's a do while loop, and what kind of problems do they lend themselves to. So a for loop is a pre-check loop. What does it mean for a loop to be a pre-check loop? Yeah. So we look at that Boolean expression first before we ever execute the body of that loop. So for loops and while loops are both pre-check loops. Okay. Whereas a do while loop is a post-check loop, which means we execute the body at least one time. Okay. So for loops lend themselves to counting type problems. So problems where we know how many times we need to spin through. So if you have a string S, we want to go through every character in the string. How many times do we need to spin through?
This one. Well, actually, no.
Try again. If I have a string S and I want to spin through every character in the string, how many times does that loop need to spin?
How many characters are in the string?
And tell me how many characters are in the string.
S.length.
S.length number of characters, right? Okay, S.length number of characters, right? While loops lend themselves to loops where we do not necessarily know how many times we need to spin. We're just going to continue to do something until some condition is met. All right. That doesn't mean you can't do counting problems with while loops. Okay. Just while loops, they don't have all the kind of counting stuff sucked into the header of the loop, creating its own little local scope. What's a scope? When I talk about scope for variables, what am I talking about?
I think you mean range.
That's possibly right if you can prove to me you know what that means. Tell me a little bit more. When I say the scope of a variable, what am I really talking about? Go ahead.
Where it exists and is recognized as the variable.
Yeah, where you have access to it. Yeah, where can I refer to this variable? All right. So if something is inside of a method and it was defined inside that method, its scope is local to that method. When that method's done, it dies. Okay. If I have it more global, it's accessible to anything that is encapsulated in that scope. Okay. So understand kind of the idea of variable scope. And where it relates here to a for loop is a for loop gets its own little local scope. So when we say something like for int I equals 0, that variable I was born with the for loop and dies with that for loop. So I can then use I again later on for a new purpose. Okay. And most of the time, if I'm using for loops for counting type problems, most of the time that's a good thing, right? Because typically I have a variable, like I've kind of advertised that when you create variables, you should name variables with meaningful names, right? Mm-hmm. I is not really all that meaningful. So typically it kind of sounds like a throwaway variable, right? So typically I, J, K, those are our 3 counting variables. And once you get past that, you're dealing with like 4th dimension. And I mean, you can do it. There's nothing says you can't have a for loop inside of a for loop inside of a for loop inside of a for loop, but once a human gets past 3 dimensions, we start getting a little wonky. Okay, so I, J, K tend to be our 3 counting variables if we have a loop inside of a loop inside of a loop. But it sounds like a throwaway variable because it is a throwaway variable. We're just using it to keep track of maybe where we are in a string or where we are in an array or something like that. And so it's nice that if we have it born with the beginning of a for loop and then it dies with the end of that for loop, we don't have to think about that variable again. We don't just have this I with the value 17 sitting in it later on that, we forget that it was 17 and we start using it for something else. And all of a sudden we have this weird output because it had a default value of 17 because we did something to it before. All right. So for loops lend themselves to counting problems. While loops lend themselves to problems where we don't necessarily know how many times it's going to spin. So kind of a classic example of it, which might not necessarily, it'll make maybe more sense when we start doing some Android stuff next week. That's when we're starting the Android programming stuff next week. So as advertised, right? Said after the, go ahead.
What's a example topic of when you use a do while?
I'll talk about do while in a second. But so for a while loop, a good example would be like when you have a computer program that says press any button to continue. We don't know how long it's going to be. Will it be 1 second till somebody presses a button? Will it be a week before somebody presses a button? So it's kind of like, has this happened yet? Has this happened yet? Has this happened yet? Has this happened yet? We don't know how many times we're going to have to spin. We're just going to keep spinning until some condition is met with a while loop. Okay, but both for loops and while loops are pre-check loops, which means that we ask that question before we execute the body of the loop. Whereas a do-while loop is a post-check loop where we execute the body at least one time. So whatever is inside that loop, we will do at least once, and then we ask the question. And a good example of that is authentication, which we do all the time. Because we need to get your username and password at least once, then we'll try to log you in. If you screwed up, we'll ask again. Make sense? Oh my gosh. I had to switch laptops this morning to get into my iCloud account on here. Because apparently I have a very, my Apple email address is older than most of you. So it's an at mac.com address, which you haven't seen in your lifetime probably, or you would have been really young. Because since then we've had a whole bunch of new ones. We had like the me.com, we have iCloud.com, and there might have been another one in there too. But in any case, I have a really old Apple ID. Well, apparently they don't like that anymore. They want me to convert to the iCloud.com account. Well, so I was trying to log into my iCloud here for these slides, and it wanted me to validate again. So it sent me, my text message code here, and so I did that, put that in, and then it says you need to validate your email address using your iCloud. Well, I don't have my iCloud set up on here. I don't have my email, that iCloud email set up in here because I don't use it for anything. It's just my login, right? Well, so from that perspective, the only way for me to check my iCloud email is by logging into iCloud, which it won't let me log into iCloud because I have to validate my iCloud email.
Oh my goodness.
You get the problem here? This is poorly written software. So I had to go grab my MacBook Pro, which happens to have my iCloud account set up on it. And luckily they sent my at iCloud.com email also to my at mac.com email, which apparently that's still legal. So I was able to get the special code from there. So now I'm in. But and Apple is supposed to be the company that's good at design.
Every company's got a flaw.
Yeah, I think most of these companies have a lot of flaws. It's like a whole lot of flaws. That's why I always thought it was funny how people demonize Microsoft. I mean, I use all the different kinds of technology just because I do this stuff professionally. But I just always found it funny that people demonize Microsoft because they were so successful. And you know how hard the problem Microsoft has had to solve over the years is? They're writing a single operating system that runs on every computer.
Well, the problem, every computer is different.
Yeah. It runs shockingly well given the problem they're trying to solve.
So basically, it's universal.
Yeah, it's far less impressive that Apple's operating system works really well because they're designing it for 7 computers, all of which they built. Right? Yeah.
Compared to like ones people built.
Huh?
Compared to ones that like people built.
Right. But once upon a time, Apple did that. Yeah, years ago, Apple they open sourced their hardware where they would allow third-party companies to build Mac clones. Because a lot of times today, people will, they don't like Apple because they're proprietary, right? And that seems to have like a negative connotation. But I think I probably talked about this in 200. Mm-hmm. But they allowed companies to build Mac hardware clones, and Apple almost failed as a company. They make a lot of money off having their own hardware and their own software. They build it in-house, charge you triple the price for it, and everything just works, but you also have to stay in their ecosystem. The second you start letting other people make money off the hardware portion of it, Apple's losing their advantage. All right. So make sure you can write loops. I might give you code to read that uses a do-while loop. That would be fair game. I probably won't ask you to write code that uses a do-while loop. Not because you shouldn't have to or shouldn't be able to, because we really haven't used it in our examples. I really want to kind of see, have you gotten out of the homework assignments what you should have gotten out of the homework assignments? I don't want to throw you a weird curveball for code I want you to write. Does that make sense? So in terms of the code you might have to write, I would go back and review the actual homework assignments and the logic you had to write for that, because I'm going to be kind of pulling from that for the widgets that I would have expected you to have learned. Okay? But I might write a do while loop in one of my code examples that I ask you, what does this guy do? Probably not even a high possibility of that, but that would be fair. I won't ask you to write a do while loop on a coding example that you have to write. All right, so we already talked about pre-check loop versus post-check loop. So there's your generic syntax for a for loop. Again, I won't ask you to write down like here what's the generic syntax for a for loop, but you should be able to write for loops. Okay, so you should know, what this first element is before the first semicolon, what's the second element, which is the Boolean expression before that semicolon, and then what's this third element. I won't, even though I think I showed it in class that you can actually have more than one variable declaration separated by commas. You can have more than one variable change separated by commas. I won't ask you to write that, and I also won't give you an example that you have to read of that. That was more of a, by the way, this is possible, but let's stick to standard plain Jane for loops for right now. All right, so you have a single variable declaration, you have a single Boolean expression, and then you have a single section where you are modifying that variable. Make sense? So no tricks. Later on, you'll learn the different ways to write some of these things, because it's actually not uncommon to have nothing here and nothing here depending on what your loop is accomplishing in very specific situations, just because for loops can be, it's a tool and you can use tools for different things. Just like at home, you've probably used a screwdriver for things that a screwdriver was never intended to be used for, like prying something off of something else. I used a spatula the other day to pry this cup holder off of a glass table. Worked great, actually. It was one of the, the really thin ones that allow you, get into the, it was perfect until I broke it. I had to get 2 cup holders off. I got the first one off and I got half of the second one off, but then I finished getting the second one off, but I broke the spatula. But I accomplished the task. It was a throwaway spatula anyways. One time it fell off the rack in the dishwasher and was on the heating element and got burned, so it's outlived its welcome. I'm going to still keep it though. You never know when I need to pry something off again. There's enough of the end of the spatula I might be able to accomplish that again. All right, so syntax for your while loop, syntax for your for loop, be able to write both of those. You don't have to write a do while loop. You should know it, but if you're focusing on what you're going to need for the exam, you should be able to read a do while loop, but I won't make you write a do while loop. Variable scope, know where you have access to a variable. So, be able to, if I give you some code, it's probably going to come into the most play where I give you some code. There's a reasonable chance that I would give you some code that forces you to prove that you understand where a variable can be accessed and where it can't. That makes sense? In fact, it might even be reasonable for me to give you some code that purposely has an error or two in it and ask you what is wrong with this code. And that a question like that might involve variable scope. That makes sense? So I might write something that tries to access a variable that technically it doesn't have access to, proving that you understand the concept of where a variable was defined and where it's then allowed to be used. So that would be a possibility. So it would be that kind of question. I wouldn't write a trick question where I throw some random error in there and say, what does this do? And then all of a sudden you have to come up with that there was an error. I would say, this code contains an error. Tell me what it is. Fair game. Error-free hello world program. In fact, I'm going to call that 85% chance it's on the exam. That should be a free 10 points, but that's graded in binary. All or nothing. Okay, so don't forget a semicolon, don't forget anything, capitalization, all the stuff. All right. Okay, and why do I want you to be able to write a hello world program? Because that becomes your starting template for any Java program, right? So I'm not necessarily advocating memorizing code in general, but there are some structures that it is advantageous to just have them at your fingertips so you can just get started with a legal program in C or C++ or Python or Java or C#, any of these languages. All right, so be able to write an error-free hello world program. Remember, it's the whole program. Public, class, whatever, open curly brace, public static void main string array args, open curly brace, system.out.println hello world, semicolon, curly brace, curly brace. All right, that's the program, as opposed to just writing the main method. I'm not asking for the main method. I want you to show me the entire functioning program that writes hello world, prints hello world. Make sense?
Yeah.
All right, be able to write methods. So what's a method? Reusable chunk of code, write once and call multiple times. I probably won't ask you a question like define a method, like what is a method? You should already know that from 200, but you should certainly be able to write methods. In fact, pretty high probability for the programming questions. I'll say write a method that does this. Okay, that's going to force you to make sure you show me what the return type is, method name, a parameter list, what inputs does it need, and then prove to me that you understand that those inputs become are now in the scope of that method and how you're solving a problem. Okay, so you should be able to create methods. The concept of all programs begin and end with main, you should understand that. I doubt I would ask it directly on the exam. That should be something that you should already be fairly comfortable with. Certainly be comfortable with strings. Know what a string is, know how to define a string, be comfortable with the length method, be comfortable with the char@. method. I think those two methods are probably, and be comfortable with string concatenation, building strings using the plus sign. All right, those should be all things that I do like questions involving string manipulation, so there's a pretty high probability that at least one of the programming questions that you have to write will involve doing something to a string. All right, those tend to be questions I like. Yeah, I technically introduced the 2 uppercase method. You know, if I wanted you to use it, I would probably say there exists a method with this header string 2 uppercase. Is this a class method or instance method? This guy right here. Instance method, how do you know? No static. How do you call instance methods?
Static. No, with the name of the class.
That's how you call class methods.
My bad. I thought you were saying that.
How do you call instance methods? This guy's an instance method because it does not have static, right? How do you call instance methods? That's how you write an instance method. How do you call an instance method? Using the instance of the class in which the method was defined. So something, so like an instance of the string class like S dot 2 uppercase. All right, make sure you understand the concept of strings, that they're 0 indexed. So if the length is 5, the legal buckets are 0 to 4. Concatenation. Plus, plus, and minus, minus, you should understand this. I probably won't ask you a question that makes you differentiate between when if the plus plus comes before, plus plus comes after. That's something that you should probably know, or at least get comfortable with over time, but I won't ask you that. I've kind of advocated that you shouldn't rely on that knowledge. Instead, just always put it on its own line. That way you don't have the different behavior, whether you were incrementing before you got the value or you were incrementing after you got the value. All right, so I won't try to trick you with that. Same thing, compound operators. If you want to use them, that's fine. It's possible I will use them in some of the code examples I give you, but not in a trick way. You know, if I say A plus equals 7, that means I'm taking A and I'm setting it equal to A plus 7. All right, so you should be able to read it, but if you never use a compound operator, that's fine. Who, what? Maybe when I was writing this originally, I had a 2 there, and then I changed it to a 7. As I was saying, you could do different things there. Because in my mind right now, I'm thinking, well, up to this point, you've only been introduced to like A plus plus, which only adds 1. So now I could say A plus equals 2. You might be led to believe that that's just how you add 2 to it, that you don't have the option to add more values. So I would have maybe changed it to a 7, proving that you can put any number there that you wanted. All right. Certainly arrays. So similar to lists in Python, memory must be contiguous. You should know what it means for memory to be contiguous. What does it mean for memory to be contiguous? And what does that mean?
That means that it's next to each other.
Yeah, so it's somewhere in memory right next to each other, right? Why do arrays need to be right next to each other in memory? Why do the buckets of an array need to live right next to each other in memory? Why is that important for arrays?
Increment like by 1 inside the array and go to the next value.
Okay.
Next sequential value.
Yeah, because the way we walk through arrays is by calculating the position of one of the buckets based on the base address of the array. Okay, so if I want to get to bucket 4 of AR, for example, I start off at AR's address, and then I take 4 steps forward to get to the address that is bucket 4. All right. So be able to create an array. I might ask you to write the line of code that defines a integer array that can hold 50 integers and then fill it up with the numbers 1 through 50. That would be a fair question to ask. So kind of structured stuff. So you should be able to define an array. So int array AR equals new int array, open square bracket, 50, close square bracket. And then write the for loop for int I equals 0, I is less than AR.length, I plus plus, fill it up with numbers. All right, so those are things you should be comfortable with. Certainly be comfortable with the new keyword. This is a real estate agent, always returns a memory address for us, right? All right, so understand the purpose of the new keyword when we're creating an array is the new keyword will give us enough memory to hold this many of these things. All right. So here's some array example stuff that kind of shows you that idea of why memory needs to be contiguous. So if I want AR at bucket 2, what this is saying is go to the base address of AR, which in this example is 100, then add to it the bucket number that I'm looking for. So in this case, it's 2 times the size of this type. I'm dealing with an integer array here, int array AR. So an int array is 32 bits or 4 bytes. So I'm going to say 2 times 4, which is 8. 100 plus 8 is 108. 108 is the memory address of bucket 2. That's why it needs to be contiguous, because we can calculate the position of a bucket and go right to that memory location. That makes arrays fast. Make sense?
Mm-hmm.
So I would say fairly important you understand this slide. If you feel like you're completely comfortable with this slide, you should be able to answer any of the questions I asked you about arrays. Understand the concept of a pointer, that it's a primitive type variable capable of holding a memory address. Also appreciate that Java doesn't give you, well, if I ask the question, does Java have pointers? What would the answer be?
Yes.
Yes. What doesn't Java have?
What abandoned access.
Yeah, so what Java doesn't have is it doesn't have a special syntax for working with memory. Okay, so we have the ability to hold memory addresses. Anytime we're using the new keyword, it's spitting out a memory address to us, so we can hold memory addresses. We just can't manipulate that memory directly like we could in C++ and C. We've lost the syntax for that. All right, call that a 20% chance of making it onto the exam. If I needed an extra question and I needed to be kind of like a shorter question based on kind of time constraints, that might be a reasonable question to ask related to pointers as they relate to Java. There'll definitely be at least one conversion question on the test, probably only one conversion question on the test. I would say that the conversion question is more likely to be convert between 2 bases, but it's also possible that it'll be convert between sizes. So for instance, here's 8 gigabytes of RAM. How many bytes is that? I could say, how many bits in 3 gigabytes of RAM? Something like that. So you should understand the difference between bits and bytes and that stuff. So be able to convert between those things. But I would say there's probably at least an 80% chance my conversion question will deal with convert from some base to some other base. That tends to be the way I go. Okay, so this was our example of a memory address. So this memory address that came out of, this was a integer array from Java, and here is that memory address. So the 277C0F21. So that's the hexadecimal base 16 number. We then converted that to base 10. So if we think about our memories being one big long street, this guy is at house number 662,441,761. Way down the street. Okay, way down the street. Okay, huh?
Can't miss it.
Yeah, can't miss it. Yeah, it's the house that looks just like the one next to it. It's the 662nd million one, ish. All right. We talked about the character class, specifically to talk about the difference between class methods and instance methods. So the character class, unlike the string class, is filled up with a whole bunch of class methods. So for instance, the toUpperCase method, this guy is a class method, right? How do you know? So when I'm looking at the method being defined here, I see the keyword static. That tells me that it's a class method. It's owned by the class. How do we call class methods? Using the name of the class in which the method was defined. So in this case, it would be character.toUpperCase. Now notice that the toUpperCase method for the character class takes a parameter, where the toUpperCase method in the string class does not take a parameter. Why is that? Remember, the toUpperCase method in the string class is an instance method. So why does the instance method toUpperCase in the string class take 0 parameters, whereas the class method called toUpperCase in the character class takes a single char as a parameter? Go ahead.
Isn't it because like the instance you already know what you're referring to? Is it you say the variable?
Yeah. So if I have a string name S and I say s.toUpperCase, that toUpperCase method already knows about S's contents. It knows what string I'm asking it to convert to uppercase. Whereas if I'm using the characters version of toUpperCase, which is a class method, you can kind of think of that as like a toUpperCase factory. Okay? The character class doesn't have value associated with it. So I'm saying with the character class, I have this toUpperCase factory. If I want to convert a char to uppercase, no problem. But you have to give it the char, because the guy who called it doesn't have value associated with it. He's just kind of the name of the building or something like that. You're going to the toUpperCase department. All right. Go ahead.
When would we want to use, or when would we want to make an instance class instead of
an instance method rather than a class method?
Yeah.
Well, kind of for that same reason. If you want to do something specific to values, so like for instance, it's common for us to create 3, 4, 5, 10 strings, right? And we might want each of those individual strings to be able to convert themselves to toUpperCase. In that case, it would make sense to have that method be an instance method so that those methods themselves know about the value in whatever string called them.
Okay.
Whereas if you kind of want to have something that you want to have available, but it's an every now and then thing, and it's not something we do to an individual instance. Maybe, for example, you want to be able to take in a string representation of a binary number and spit out the decimal equivalent, that kind of conversion type thing, right? Well, that's not something that every single copy of a string needs to be able to do. So you wouldn't say s.convert to decimal. And S2.convert to decimal. That's really kind of here's an algorithm that knows how to do something. I'm going to toss that guy a string, and he's going to spit me out a decimal. So that would be a method we only want to actually exist one time, right? So we would write that as a class method so that it only ever actually exists one time, as opposed to an instance method, which each individual instance of a class gets its own copy. That's going to probably make some more sense when we get into the Android stuff, because in the Android class, the Android stuff, I'm going to introduce another design pattern called the singleton design pattern, which I think you've seen from the Unity stuff, but we're going to have a global class filled with class stuff that are owned by the class that allows us to share stuff between multiple screens in our application. Okay, so on the exam, I won't ask you questions that really forces you to explain why you might personally write an instance method versus a class method. You should be able to see a method definition and tell me whether it's an instance method or a class method, and you should then also know how to call it. But I won't ask you to explain the rationale behind why it was chosen to be an instance method or a class method, even though you should have a fighting chance at making the answer of saying that, but it's a little bit complicated, right? But definitely you should be able to identify a method, whether it's an instance or class, by its definition, and then call it appropriately. Yeah, so these are, this is that slide that everybody should also commit to memory. So class methods, they're defined, they have static in front of them when you're seeing them defined. When they're being used, they're called using the name of the class in which they were defined. For instance method, when they're defined, they do not have the static keyword in front of them. When you use them, you're calling them using an instance of the class in which the method was defined. So tattoo this on your soul. Or I guess do one of those cattle brand things. I don't know, whichever is more painful. So whichever. I don't know a whole lot about soul tattooing, but the cattle brand thing sounds bad. So, yeah. So super important slide. Okay, this is on the exam multiple times in one way or another. You should understand this slide 100%. Understand this slide 100%. This slide 100%. Multiple times I've said this, recorded, right? Okay. What's this?
What recording?
What recording? What are you talking about? All right, so I probably won't ask you about this specifically. I mean, this idea of a static context. We've talked about it. We talked about when you have a static method, you don't have access to that variable this, but we really haven't had enough real life examples of this for it to really be a clear question I can ask. So I wouldn't spend time worrying about what's a static context and what's not a static context. It's pretty easy. If a method is a static method, it's a static context. But what does that mean? That means when you're inside of that method, it doesn't know about instance things. It doesn't know about this. It doesn't know about super. It doesn't know about fields. It just knows about what it has. It's local stuff. Okay? Non-static contexts, like in instance methods, they know about fields. They know about the this keyword. They know about the super keyword, all that stuff. Inline if statement, more of a trivia thing. I won't ask you anything. You won't have to write an inline if statement. You won't have to read an inline if statement. Not that it's not important for more of trivia knowledge, especially for reading some older code and situational code today, but won't be something that's on the test. All right. Definitely arrays. Again, you need to know those. Definitely understand the difference strings versus arrays. So strings are collections of char primitive types, whereas arrays are collections of like types. Doesn't have to be primitive types, like types. You can have an array of objects. You can have an array of strings. You have an array of ints. You can array of chars, whatever you want. So strings are specifically a collection of chars. Arrays are a collection of like types. Now, strings are also read-only. If you want to modify a string, let's say you want to remove the vowels from a string, you have to build a brand new string. And usually the way you would think about it is rather than removing the vowels, you would go through the original string, keeping all the non-vowels. Those are the ones that make it into your new string that you're building. So strings are read-only. We cannot directly change a particular bucket of a string. If I have a string named s and I say s.char@3, that gives me a copy of the char that lives at bucket 3. That's not a two-way door. I can't say s.char@3 is equal to a question mark. Okay? Char@3, well, the char@ method boils down to a value. The value it boils down to is a char. Doesn't let me put an assignment operator after it and set it to a value. It's a one-way street. It's read-only. Make sense? Strings are read-only. As opposed to arrays are read-write. I have an array named AR. I can get the value at bucket 3 by saying AR square bracket 3 close square bracket. I can also set AR at bucket 3 equal to something. AR at bucket 3 is equal to, let's say if it's an array of integers, is equal to a 7. So it's read and write. Make sense? Okay. Also, arrays are fixed size. When we first build an array, we have to define with the new keyword how many buckets that array will have. And if we want to add buckets to it, we have to build a brand new array that's bigger, copy all the old stuff over, add the new stuff, and then we can set the old variable equal to the new array, effectively burning and letting garbage collection pick up the mess that we just left. So this is the example we used in class is if you want to build a porch or a patio on your house, you have to build a brand new house that's the copy of your original house with a little bit more yard space to build the patio, then burn down the old house. Okay, move all your crap. So doesn't seem real efficient in real life, but computers, who cares? We have lots of RAM. All right, so another important slide, strings versus arrays. I like asking manipulation questions for programming questions. So I would say you will either be manipulating a string or manipulating an array, or even more probably both. If you have 3 programming questions, you'll probably have one where you have to work with a string and another one where you have to work with an array. I like those kind of questions. So that means you should be real comfortable with for loops. You should be real comfortable with strings, real comfortable with arrays, and changing values in them. And remember earlier I kind of mentioned that I'm not going to give you really hard logic to do in those programming questions. I want you to show me that you have a competency in those kind of those fundamental abilities. Writing a loop that spins through every element of a string, writing a loop that spins through every element of an array, asking questions about the current element we're looking at, and then doing something related to the question you just asked. So not real crazy logic type stuff, but proving that you're able to use those fundamental abilities. All right. This is more pointer stuff. We talked about automatic garbage collection. I probably won't ask you a specific question about that. It's more just how memory's cleaned up. We talked about parallel arrays. That was from the book. That's where you have 2 arrays that have the same number of elements in it, where bucket 0 of one of them is somehow related to bucket 0 of the other one. I would say it's possible. I won't ask you to solve a problem using parallel arrays. That maybe starts getting into that more logic connected thing, but it would be possible for me to give you code and say, what does this do? And I might use parallel arrays in that. Okay. And then you should certainly be comfortable with pass by reference versus pass by value. Strings are passed by value, arrays are passed by reference, primitives are passed by value, objects are all passed by reference. Questions, comments, concerns, bribes? Okay, class next time I'll provide my PayPal address. Okay, in case things get sketched during the exam. All right, remember today, student, faculty, staff, Bible study, God and Grub. Just go down to the cafeteria, sign in, grab a tray, take it down to the terrace room. We get free lunch and Bible study with Pastor Smith. I will save you a seat at the table. And I will see everybody on